Water has always been important and life-sustaining for humans and is essential for survival of all organisms on our planet. With a growing population and the pressures on aquifers to supply quality water, farmers' wells must go deeper and lift the precious water higher, requiring larger pumps and machinery. Water harvesting isn't a new idea. For centuries, it has been relied upon to supply water for farms and residential needs. Since most of our rainfall occurs in large storm events, the ability to store and collect rainwater is paramount. Farmers and ranchers know the value of stored water.
Protecting your well in that area really tends to protect your well. So, we hear criticism of rainwater harvesting sometimes that, well, if it's a drought, you don't have any rainwater. Why does it matter? Well, if you haven't used your well all year because you've used your rainwater system, then your well is that much better able to take you through that drought. And that's where it really does matter. So that's where you protect your well year round. And so when we do have a drought, we don't have wells running dry.
The pressing need for sustainable fresh water is increasing the use of roof-based rainwater collection systems for potable and non-potable uses.
You're using an immediate source of water versus an aquifer that's precious and that's being shared with your neighbors. So any kind of conservation you can do in terms of reducing the amount of water that you're taking out of the aquifer is not only going to benefit you in the long run, but also your neighbors and everybody else depending on well water.
How does it work? The basic concept of harvesting rainwater is simple. Rainwater is mostly collected from roofs of buildings. It flows through gutters and downspouts by gravity into a storage tank where it is held until reuse.
At this project, we were blessed by having some really nice grade as well, that it was going to be really easy to gravity feed all that water to the tank because we've got that dip down at the end of the property. So we had the gutters go in first. Mr. Bates came out, hung gutters for us. We did, if you can see in the pictures, they're slightly kind of small gutters. And so we have two downspouts paired a lot of places. That was because we were worried about snow ripping gutters off as it came off the houses. So we actually did slightly smaller gutters and more downspouts to carry the larger storms. Then Red Oak came in and they attached to each of those downspouts and dug drain lines just like you dig on any other building, your house, a commercial building, school, anything like that. Put in HDPE drain lines all the way down. Next thing they put in line were the vortex filters, which are there to keep debris out of the tank.
One of the most important challenges of rainwater harvesting is the removal of organic debris in order to make the water available for reuse.
Water comes in through the side of the pipe. There's a stainless steel mesh there, and it's 380 microns on the inside, and 380 microns is sort of like a medium coarse sand. Something in that neighborhood. And then outside of it, there's actually a coarser mesh with a little air gap in between them.
Overflow from rainwater harvesting tank systems can be used to refill aquifers, water pastures, or released to go downstream.
So this is the overflow from the tank and that vortex filter. Like we talked about, debris and things like that we don't want in the tank will come out here. Also, if the tank starts to overflow, if we've had too much rain and haven't used as much water lately, it'll overflow right here. In rainwater harvesting systems, one of the main things you're worried about is buildup of a lot of organic debris, leaves, things like that, because that's a lot of what you get coming off your roofs. I mean, like we all know, it's what you find in your gutters at your house, things like that. And if that gets into a storage tank, it starts to break down, can lead to bad odors, discolored water, potential for bacterial growth, things like that. And then here's our tank over here. We have a 20,000 gallon tank. It's all buried right underneath here. It's made out of modular plastic pieces that look similar to milk crates that we got from ACF Environmental. They're then wrapped in a waterproof liner and a geotextile fabric. And they basically dug out a hole for the excavation, came in and built the tank there in place, wrapped it up. It's got 20,000 gallons of storage there. So that's one of the really nice features about using this tank system, and part of why we went with it for this project is that it's not as invasive to bring it in. You can bring in the materials in a pickup truck if you need to. So getting to sort of less easily accessed areas is actually a lot easier with this system. It's also nice because you can rearrange it however you like. You could make a really long skinny tank if you wanted to. You can make a very square tank. We have a fairly square tank there, but you can really design the tank any way you want to. So in projects where you have a limited area or things like that, it can be nice to redesign the tank as you would like. The water is going to be pumped from this tank back to the chicken houses for use. The pump is going to be sitting in a well casing, just like you'd have a well casing on a well at home that sits down in the tank. It pumps from there to a pressure tank, again, just like on a well at home. From the pressure tank, it goes through a sediment filter and then an ultraviolet light. So we're making sure there isn't any bacteria remaining in the water before we distribute it. And the whole system will be backed up by the well also.
This is the first situation that I know of where we've tried to capture water off of poultry houses and run it back and reuse it.
1 inch of rain on the total roof area will generate about 33,200 gallons of water.
Right now we know we're going to use the water for cooling. We're going to put a UV light on it to treat it for bacteria and pathogens. We're going to filter any sediment and anything like that that gets out of it.
We hope that this project will help get other farmers interested in rainwater harvesting and will help us learn how rainwater harvesting systems can be improved to fit their needs.
Funding for this video was provided by James River Association and Altria. Funding for the project was provided by the National Fish and Wildlife Foundation, Altria, Chesapeake Bay Restoration Fund, and the National Resources Conservation Service. Technical partners are Center for Watershed Protection and Rainwater Management Solutions. Project partners are Piedmont Soil and Water Conservation District and Longwood University. For more information on Virginia's agricultural cost share programs, please contact your local soil and water conservation districts.